Naive epistemology. Children use social cues when determining what others know. Presented at the 2015 Society for Research in Child Development Biennial Conference in Philadelphia, Pennsylvania. Paramount to determining whether someone can provide accurate information is the ability to determine what that person knows. Although what someone knows is generally unobservable, children will often use observable informant features, such as traits, behaviors, and social categories, to make inductive inferences about informant's knowledge. However, children may be making inferences from informant features without completely understanding what those features represent. Today I'll be presenting results from two studies that demonstrate that young children seem to be using socially relevant, or social, features for making epistemic inferences about informants. Even young children recognize that for an informant to be trustworthy of providing accurate information, she must have the knowledge and ability to provide accurate information, as well as the intention to do so. Because knowledgeability and intent are unobservable psychological features of informants, learners must make predictions about informants using what they can observe, such as an informant's age, expertise designation, the informant's nice or mean behaviors, or even the informant's accent. In fact, as learners engage with trustworthy and untrustworthy informants over time, they begin to make connections between certain observable features of informants and whether those informants have been trustworthy. Sometimes these features, like expertise, are truly relevant for whether an informant has knowledge. Other traits, like niceness, may be more relevant for whether an informant intends to help or deceive. Although children seem to be relatively adept at recognizing that intellectual cues can lead to competence and certain social cues can lead to benevolence, other evidence suggests that children do not always weigh informant cues appropriately when evaluating others. For instance, much research demonstrates situations in which children make behavioral, trait, and knowledge inferences based on one informant feature, even if that feature is irrelevant to the domain being predicted. For instance, work by Stipek and Daniels demonstrates that children predict a classmate who they think is smart is also likely to be better at reading, sharing, and even jumping hurdles than a classmate who is not smart. But why might this be the case? One possibility is that children expect consistency in people's behaviors and traits, such that they would infer someone who is good or bad in one domain is likely to be good or bad in all other domains. A second possibility is a methodological one. Children may be led to make seemingly irrelevant inferences by pedagogical cues. When children are given only one characteristic by an experimenter, they may determine that they are supposed to use this characteristic to make predictions. Work in pedagogical reasoning suggests that children are likely to view the experimenter as a helpful and trustworthy source of information, and thus they view the experimenter's selection of the one particular characteristic as purposeful and inferentially sufficient. And so, irrelevant characteristics, when communicated by a trusted informant, may support the use of valence-consistent predictions. Therefore, to determine how children use informant features for making inferences about an informant's knowledge and intent, we provided children with both social and intellectual features, allowing children to use or ignore information as they saw fit. Data from two of our projects demonstrates that children indeed seem to use social cues when making epistemic inferences, but they do not use intellectual cues for making predictions about social behavior. Our first study examined how children weigh prior history of accuracy, along with niceness and meanness information, when making predictions about an informant's knowledge and behavior. 110 preschoolers were introduced to two informants who were described as mean or as nice, and they witnessed each informant accurately or inaccurately label a series of 4 familiar objects. Whether they heard about the informant's niceness or meanness first, or whether they first watched the inaccuracy or accuracy trials, varied between subjects. To demonstrate accuracy and inaccuracy, we used the standard epistemic trust paradigm, in which the two informants were shown an object familiar to children, for example, a cup, and children watched as one informant correctly labeled the object and one informant incorrectly labeled the object. We had a between subjects manipulation. Some children saw informants who were consistently valenced, such that the nice person was also the one who labeled items correctly, and the mean one was the one who labeled objects incorrectly. In the other condition, children saw informants who were cross-valenced, such as the nice person was the informant who labeled objects incorrectly, and the mean informant was the one who labeled objects correctly. After establishing the two informants' history of accuracy for labeling objects and their relative niceness or meanness, children watched as the two informants labeled a series of 4 unfamiliar items and were asked which of the two informants was most likely providing the right name. However, what we're most interested in looking at today are the next two set of items. In addition to the novel item trials, children were also asked to make inferences about the informant's knowledge. For this study, children were asked to choose which of the two informants had knowledge about 4 general factual items. For example, children were asked which person knows that cats can see at night. In addition, children were asked to make social behavior inferences. Children were asked, for instance, which person shared their toys with somebody. Our first hypothesis was that children would use an informant's social feature for making inferences about that informant's knowledge. If our hypothesis was supported, we would see that children would attribute a larger proportion of knowledge to the accurate informant in the condition in which he was also nice than in the condition in which he was also mean. However, if our hypothesis was not supported, we would see that children would attribute the same amount of knowledge to the accurate informant, whether he was also described as nice or as mean. Indeed, we found that children attributed more knowledge to the accurate informant in the condition in which he was also nice than in the condition in which he was mean. Moreover, children's knowledge attributions in the nice and accurate condition were above chance levels, and their attributions in the mean and accurate condition were at chance levels. Our second question was whether children would use intellectual features for social behavior inferences. If this hypothesis was supported, we would have seen children attribute larger proportion of nice behaviors to the nice informant when he also demonstrated accuracy. However, if the hypothesis was not supported, we would see children attribute the same amount of nice behaviors to the nice informant, whether he demonstrated accuracy or inaccuracy. In this case, our hypothesis was not supported. Children seemed only to be using social information when making social behavior inferences. They preferred to attribute nice behaviors to a nice informant above chance levels, whether he was also accurate or inaccurate. In summary, children are considering an informant's niceness and meanness when they're making predictions about both that informant's knowledge and that informant's social behaviors. However, children are not using an informant's history of accuracy to make predictions about the informant's social behaviors, but at least they're considering it when making inferences about their knowledge. The second study examined how children weigh expertise as an intellectual cue, with niceness and meanness as a social cue. A few things varied between this experiment and the previous one. First, we used expertise information as our intellectual cue, as opposed to history of accuracy. This allowed us to provide a cue that was more similar to niceness and meanness, in that it was described to participants as opposed to demonstrated to them. Second, we presented 3 informants instead of just 2, and participants were asked to attribute knowledge and behaviors to them independently. They did not have to choose between the informants. Importantly, we had 3 between subjects conditions, between which expertise and niceness and meanness were counterbalanced. In the nice expert condition, the nice informant had expertise, whereas the neutral and mean informants did not. This was most similar to the consistent valence condition in the previous study. In the neutral expert condition, the neutral informant had expertise, whereas the nice and mean ones did not. And in the mean expert condition, the mean informant had expertise, whereas the nice and neutral informants did not, and this was most similar to the crossed valence condition in the first study. Again, for this study, unlike the first, children's attributions were independent, such that they could attribute an item to one, two, or all three of the informants. We had 2 measures of knowledge, 4 items that were relevant to the expertise category, in this case, bird items, and 4 items that were more distantly related, which we called tangential items, in this case, items about plants. In addition, we had 4 nice behaviors and 4 mean behavior items. Looking at an example item, children were first told a fact, such as, "Some people know a lot about what makes grass green." Then they were asked whether each informant would also know that information. Does this person know about what makes grass green? What about this guy? Does he know about what makes grass green? What about him? Does he know about what makes grass green? Our first hypothesis, like with the last experiment, was that children would rate the expert as having more knowledge when he was also nice. Because we did not see any differences between the 2 conditions for which each informant was not an expert, we collapsed across those 2 conditions for that informant. Here, the y-axis is the proportion of knowledge attributed to each informant. The x-axis shows each informant first for the conditions in which that informant was an expert. So here, the nice expert condition, the neutral expert condition, and the mean expert condition for the nice informant, neutral informant, and mean informant. And then for the conditions in which the informants did not have expertise. So this is attributions for the nice informant in the mean expert and neutral expert conditions collapsed. Attributions for the neutral informant in the mean expert and nice expert conditions collapsed. And attributions for the mean informant in the nice expert and neutral expert conditions collapsed. Now we had 2 measures of knowledge for this study: expert relevant knowledge and tangential knowledge. First, let's look at the expert relevant items. If our hypothesis is supported, we expect to see the proportion of knowledge items attributed to the informant to be higher for the nice informant and lower for the mean informant, regardless of whether that informant have expertise. However, if our hypothesis is not supported, we may see that children ignore the social information and attribute knowledge to each informant when he's the expert above chance levels and below chance levels when he's not the expert. Interestingly, when looking at knowledge attributions for the informants when they had expertise, we see a trend towards an effect of the social information. Specifically, children attributed marginally more expert-relevant knowledge to the expert in the condition for which he was nice than in the condition in which he was mean. When the informants did not have expertise, this effect was significant. It is interesting to point out that when the nice informant was described as having no knowledge whatsoever about birds, children still attributed knowledge to him above chance levels. And while they attributed knowledge to the neutral and mean non-experts below chance levels, they still attributed more knowledge to the neutral non-expert than to the mean one. Our second measure of knowledge attribution was tangential knowledge. In this case, we find significant differences for both when the informants had expertise and when they did not. Our second research question was whether intellectual features influence social behavior inferences. Here, the y-axis is the proportion of behaviors attributed, and the x-axis separates attributions to each informant in each of the conditions. So first, we have attributions to the nice informant in the nice expert, neutral expert, and mean expert conditions, and then attributions to the neutral informant in the nice expert, neutral expert, and mean expert conditions. And finally, attributions to the mean informant in the nice expert, neutral expert, and mean expert conditions. If our hypothesis is supported, we'd see a bump in the number of nice actions attributed to the informant in the condition in which that informant has expertise. In contrast, if the hypothesis is not supported, we'd see that the number of nice actions attributed to the informants would vary only by whether the informant was nice, mean, or neutral, and not based on whether that informant had expertise. Indeed, for nice behaviors, we see that children attribute more nice actions to the nice informant than to the mean one. However, this does not vary based on whether the informant had expertise. So the nice informant was seen as being just as nice whether he had expertise or someone else did. The same finding is true for attributing mean actions. More mean actions are attributed to the mean informant than to the nice one, and the attributions do not vary based on which one has expertise. In sum, like with the first study, we found that children seem to be using social features to make inferences about knowledge, but children are not using intellectual features to make inferences about social behaviors. Taken together, our research suggests that when given both social and intellectual features, children make broader inferences from social features, using them to make both epistemic and social behavior inferences, but narrow inferences from intellectual features, using them only to make inferences about informants' knowledge. One potential reason for why children make broader inferences from the social feature than from the intellectual one may have to do with whether children conceptualize the given features as stable personality traits. Specifically, children may be more inclined to make broader or even cross-domain inferences based on what they perceive as stable and enduring personality traits. In the current study, children may have been using the descriptions of niceness and meanness to make inferences about those informants' personalities, but not using the accuracy or expertise information to make similar inferences. After all, expertise by definition is having domain-specific knowledge. Children may be used to applying knowledge much more narrowly than behavior. I'd like to thank the Coco Sci Lab at the University of Louisville for their helpful feedback, as well as the undergraduate research assistants at the University of Texas at Dallas Think Lab. For more information, please feel free to contact me, Ashley Landrum, at landrumar@gmail.com.